Hi, let's start with a new section, from decision trees to random forests and other ensemble methods. In this section we'll introduce three methods of creating ensembles: bagging, boosting and stacking. First, we'll apply bagging to the decision trees introduced in the previous section to create a powerful ensemble called random forest. Then we'll introduce boosting and the popular add-a-boost algorithm. Finally, we'll use stacking to create ensembles from heterogeneous base estimators. Now we move on to the first video of this section that deals with bagging. In this video we'll learn about bagging and Bootstrap resampling. Then we'll apply bagging to a single decision tree and a random forest. Bootstrap aggregating, or bagging, is an ensemble meta-algorithm that can reduce the variance in an estimator. Bagging can be used in classification and regression tasks. When the component estimators are regressors, the ensemble averages their predictions. When the component estimators are classifiers, the ensemble returns the mode class. Bagging independently fits multiple models on variance of the training data. The training data variants are created using a procedure called Bootstrap resampling. Bootstrap resampling is a method of estimating the uncertainty in a statistic. It can only be used if the observations in the sample are drawn independently. Bootstrap resampling produces multiple variants of the sample by repeatedly resampling with replacement from the original sample. All of the variant samples will have the same number of observations as the original sample, and may include any observation 0 or more times. We can compute our statistics for each of these variants, and use these statistics to estimate the uncertainty in our estimate by creating a confidence interval or calculating the standard error. Let's work through an example of bagging. Here we've created a sample of size 10, and then calculated the mean. Then we've resampled the original sample and performed bagging on it. We again calculate the mean. Run the script. You'll see this output. You can see the difference in the mean of the sample and the resample. Bagging is a useful meta-algorithm for estimators that have high variance and low bias, such as decision trees. In fact, bagged decision trees ensembles are used so often and successfully that the combination has its own name, the random forest. The number of trees in the forest is an important hyperparameter. Increasing the number of trees improves the model's performance at the cost of computational complexity. For random forests, the algorithm selects the best from only a random sample of the features at each node. Now let's train a random forest with Scikit-learn. Here's the code to do that. First, we import the necessary packages. Then we use make classification to create an artificial classification dataset. This convenience function allows fine-grained control over the characteristics of the dataset it produces. We create a dataset with 1,000 instances. Of the 100 features, 20 are informative. The remainder are redundant combinations of information features or noise. We then train and evaluate a single decision tree. Let's run this and look at the output. You can see the precision, recall and F1 score for the decision tree here. Now let's do it with a random forest. We've used 10 decision trees. Run this. You can see that the random forest's F1, precision, recall and F1 scores are greater. That's correct. That's all for this video.